this in because I am trying to get done before the end of the period. I really remember over the weekend I tried to give you a little bit of break, but at this case, I'm not sure we're going to get done. All right. So again, generally what happens when we start a new chapter is the first section is kind of easy, and that is the case in this particular section. But I would like to talk to you real quick about the interior angles of a convex polygon. Remember, that sounds kind of complicated, but convex, all right, convex polygon, yes, we did do this on the IXL, so it really should be kind of a quick little review here. All right, the sum of the interior angles of a convex polygon, there's a formula, and the formula is n minus 2 times 180. Now, how do they come up with that formula? They come up with that formula because the interior angles of a triangle always add up to what? They always add up to 180. All right, and if they add up to 180, if you will think about, for example, a quadrilateral can be divided into what? 2 triangles, right? If you have a pentagon can be divided into what? 3 triangles, right? Hexagon can be divided into what? 4 triangles. So that's how they're coming up with the formula n minus 2 times 180. That's the sum of the interior angles of a convex polygon. Now, in question number 3 here, why is that considered a convex? The reason it's convex is because if you were to draw any diagonal, the diagonal would be on the or in the interior of the polygon. All right, same thing with number 4. That is considered a convex hexagon because, again, if I draw any diagonal, the diagonal will end up where? On the inside. All right. If you have something that's concave, and I'll give you a quick example of something that's concave, right? When you draw all the diagonals of a concave, and this was what I mean by concave. All right. This is still considered a polygon, but it's considered concave. Now, the reason, again, why it's called concave is because as I try to draw the diagonals from here to here would be considered a diagonal. That diagonal is on the exterior of the polygon. If I try to draw, for example, in question number 3, if I try to draw a diagonal, the diagonal would be in the interior. Come on now. Please watch. Please pay attention. Trying to make it easy on you. All right? So again, the formula, very simple, all right? The sum of the interior angles, n minus 2 times 180. That's the sum of the interior angles, all right? So if you have a decagon would have how many sides? 10. So the sum would be 8 times 180. 1,440 degrees. That is exactly correct. All right. Now a pentagon has how many sides? 5. So again, the formula is simply 3 times 180, which is 540 degrees. All right, again, very easy, very basic. All right, now let's take a look at number 3. All right, number 3, we would just say that is a quadrilateral, and that should be pretty standard. Quadrilateral adds up to 360. All right, so if you're writing your equation here, you would simply say that 10x is equal to 360. So in this case, x is 36. All right, now it does say find the measure of each angle. So now we have to come in here and say that's 36 degrees, 72 degrees, 144 degrees, and 108 degrees. All right, those are the 4 angles. So everybody agree with me? That's very easy. Very easy. All right, let's take a look quickly at number 4 now. All right, a little bit different here. We have a what? Hexagon, right? So if we have a hexagon, then we have what? N minus 2 times 180. And in this case, there are 6 sides, so it would just be 4 times 180, which I think is 720 degrees. All right, now we do have a little issue here. My little hand as I was copying this got in the way. So let's call that an 8. Let's call that, I think it's x minus 8, unless, yeah. Is that what it is? Okay. So here we go. Now, how many x's do we have? 6x. And if we add the constants, what are we thinking? Is it just 6x? Yeah, thank you. 6x is equal to what? 720, so x is equal to, I'm happy, x is equal to 120 degrees. All right? And so now it's just a matter of saying that angle A is what? 122. And angle B would be, I think, 112. And C would be 127. And D would be 117. E. And then F. All right. Yeah, I don't think that's that bad. All right. All right, now here it says, the Wonder Wheel at Coney Island in Brooklyn, New York is a regular polygon with 16 sides. All right. What is the measure of each interior angle? Okay. Now, does anybody remember what does regular mean? What does regular mean?
It has like no curves and it's closed. All the sides are equal. All the sides are equal.
Yeah, regular. Now remember, when something's regular, right? Regular just means all the sides are the same, all the sides are congruent, and then all of the what? Angles are congruent. So now, it's real easy. I never really understood why kids had a little bit of trouble with this, trying to memorize this formula. But look, right here. This n minus 2 times 180 gives what? The sum. Right? And then you just divide it by the number of sides. Exactly right. So the formula for the interior angle would simply be n minus 2 times 180 divided by n. That is the measure of each interior angle. Now, the only way you know is it has to say that it's what? It has to say that it's regular. All right? If it's regular, all of them are equal. All right, so how many sides does this have? 16. So we would then say 14 times 180 divided by what? Divided by 16. All right? So somebody go ahead and tell me what that is about. About 157.5 degrees. Is that right, guys? Somebody double check. 157.5 degrees. Now, again, I just don't think that's that bad. All right. Any questions? All right, let's move on. The measure of an interior angle of a regular polygon is given. Find the number of sides. All right. So now, here's what we have. We have the interior angle is what? 150. So now you have to tell me that 150 is equal to n minus 2 times 180 over n. Now let's see your math skills and tell me how many sides that is. Working backwards. Let's go. Shh. I want everybody to figure it out. What? Somebody said it's 12. Right? Now, if you're having a little bit of trouble, just remember you can make it a proportion and cross multiply. right, that's what we're doing here. All right, come on now. Everybody, I don't really want to do the math on that. All right, unless you're just going, man, I forgot my pre-algebra days, how to solve that. Anybody have any issues with n is equal to, tell me again? 12. When you cross multiply, you get 150n is equal to 180n minus 360. Come on now. 150 times n is what? And then I just distributed. Right? So you end up with 30n equals 360. All right, since you did so good on that one, everybody has to try number 7 real quick. We're waiting for everybody else. We're waiting for everybody else. And like I said, I really don't want to do the math on that. I want you to practice, especially if you missed number 6. Make sure you understand how to solve that proportion. Anybody having a problem? So what did we say the answer was for number 7, somebody? N equals 36 sides. Anybody else? Anybody else? Anybody else? Let me see what else is going on. Okay, question number 8. Okay, now the last note I need you to remember, and to some degree, what I want to do is I want to take one of these regulars. I wish I could. I don't really see one. Let me find a regular polygon. All right. Well, everybody look right here. All right, since this is kind of an outline, just kind of watch here just for a quick second so I can try to show you something. All right. Wow. All right, here we go. So I'm trying to draw this right here. Now, what I'm trying to ask you about is the exterior angles. All right. Now, as I was looking at the exterior angles, all right, what I want to try to demonstrate to you is that the exterior angle is just an extension of each one here. All right. Now, when I first was taught about these exterior angles, I never really understood why that they say that there are how many exterior angles. All right, so if you're looking at that right there, they're telling me that there's 1, 2, 3, 4, 5, 6, looks like 7 exterior angles. Is that look right? Right. But when I was thinking it through, if I were to just extend those lines, to me it seems like there should be what? Yeah, to me, if I were making up geometry rules, I would say that there are what? There are 14. And I think hopefully everybody in here is kind of saying, yeah, I can kind of see that also. Now, some people even ask me, well, then why can't there be like 21? All right, which is another reasonable response there. Why can't there be 21? Well, 21 didn't make sense to me because this interior angle would be the same as this angle right there. Do you agree? Right, so I don't think we could call them the same. Does everybody agree with me on that? But I was a little stuck with why are they calling only one of the angles an exterior angle? All right, I really don't even have the answer for you on that, other than the fact that the exterior angle is just the number of vertices. All right, the number of vertices. All right, now, like I said, if I was making up geometry, I would say there were 2n exterior angles. All right, but that's not the way they decided to do it for whatever reason. All right, is everybody hearing me? Each interior angle, 1, 2, 3, 4, 5, 6. All right, so I'm just assuming if there's 6 interior, there must be what? 6 exterior. All right, like I said, I don't really know the logic behind why they would say that, but to me, that's what they're using. All right, so there are the same number of exterior angles as there are what? Interior angles. Now, the funny thing about the exterior angle is that the exterior angles, the sum of the exterior angles is always 360 degrees. All right, the sum of the exterior angles is always 360 degrees. All right, so I need you to remember that. The sum of the interior angles is always n minus 2 times 180, but the exterior angles always add up to 360. All right, so when somebody asks you about number 8, are the exterior angles equal here? No, but we do know that they add up to what? We do know that they add up to 360. So all we're doing is we're just taking the fact that we know that they add up to 360, and we're saying 360 is equal to, then how many x's do we have? All right, so somebody else. 4x plus what? 152. All right. Now, some of you guys, I've tried to show you this again because I think it's important to be good with numbers. To me, I would want you to be able to look at that and say, it'd probably be better for me to just divide by 4 first. Right? Did everybody see that? So then if I take 360 divided by 4, I get what? 90 is equal to x plus, and now 4 goes into 152, 38. I just think that's easier. And so now we can just safely say that x is equal to what? 52. Now, some of you guys that are using your calculator too much, this is what we're trying to do in class. Try to do it without a calculator, and then when you're home, I really don't care if you use a calculator. All right? But some of you guys that need to get better, I would like for you to be better at the mental math. All right? So now let's look at question number 9. All right, again, the exterior angles must add up to what? 360. Now, the other thing, though, look up here on the board because I think I failed to mention this. Look right here. This is an exterior angle. This is the exterior. You see how I'm going in the same order as I'm going either clockwise or what? I can't have one clockwise exterior and one counterclockwise. Does that make sense? Yeah. All right. So they're always going to run in the same direction. All right. So again, we just say 360 is equal to. Again, this is nice. Divide by 4 first, so we can see. And now, when you're subtracting 22, remember you subtract 20 first, and then you subtract 2. All right? So there you have x equals 68. All right, x equals 68. Everybody good with this? All right, I told you that's very easy. All right, now, here we go. It says, find the measure of each exterior angle. All right. Now, again, it's what? It's regular, right? So all we have to do is take what? 360 and divide it by? Right, 360 divided by the number of sides. So number 10, it would be what? 90, and then 9 degrees and 45 degrees. All right, for those of you guys who want to divide by 8, sometimes when you're dividing by 8, it's easier to divide by 2 3 times. All right? All right? 4 once and 2 once. Agreed? If you divide by 8, you can divide by 2 3 times. And she said, or you can divide by 4 twice. And I said, no, you'd be dividing by 4 and then dividing by 2. All right? Now, I do, honestly, there's nothing really that difficult here. All right, but I'm going to try to show you a little shortcut now. All right. So look right here. This is what I'm asking about now, as far as the interior angle. All right. N minus 2 times 180 divided by n is equal to the what? Is equal to, no, you're right. It's equal to the interior angle. All right. It's equal to the interior angle. All right. And then we have the exterior angle. All right. The exterior angle we said was equal to 360 divided by n. Of course, if it's regular. All right. If it's regular. Now, what's true about the interior angle and the exterior angle?
They're all the same amount.
The interior angle plus the exterior angle is always equal to what? It's always equal to 180 degrees. All right? It's always equal to 180 degrees. So if I said to you, watch, if I said, what is the interior angle of a 9 sides? If it has 9 sides. Now, this is just mental math. Here's what I'm trying to tell you. You should be able to say that the interior angle of a regular 9-sided polygon would be 140. Exactly correct. Now, how did you do that so fast?
So I did 360 divided by 9, and I got 40, and then I did that.
100% correct. So listen to me. I'm just trying to save you some time here. All right, so using the exterior angle is always easier in my opinion. All right, so if you want to find the exterior angle, you just divide 360 by the number of sides. Right? So in this case, 360 divided by 9 was 40. And so now we're doing the exterior angle subtracted from 180 is the interior angle. So again, that's just straight mental math. That's why when some people, when I was asked them earlier, you can do the math so quickly if you understand the relationship between the exterior angle and the interior angle. Is everybody with me on this? All right. Now, again, guys, this chapter, particular chapter, there's just a bunch of rules. All right. And again, this formula is one of the formulas that you will see on the SAT and ACT. All right, so I want you to try to think about that. All right, these several rules. Now, your homework here says 1 through 19. Make sure you're writing this down. 1 through 19, 21 through 24, 26 through 37, and 39 through 41. I don't really think there's anything difficult. Nothing difficult. I'll show you one more time. We have 1 through 19, 21 through 24, 26 through 37, 39 through 41. And we have some time in class to finish up. All right? Get busy, please. All right? Try to get it done.
What is today's date? 26.
Is that what you want? The interior angle plus the exterior angle is always equal to 180.